You are holding approximately 7 items in working memory right now. The sentence you just read, my voice, your conscious thoughts about this topic. Add even one more thing, and something drops out. Working memory is the bottleneck of cognition. Everything that enters consciousness must pass through its limited capacity, and the design of learning, technology, and communication should be shaped by its constraints. Working memory is the cognitive system that holds and actively manipulates a small amount of information in conscious awareness for use in ongoing tasks. It is not simply a passive storage buffer. It is an active workspace where information is combined, transformed, and used for reasoning, comprehension, and problem-solving. Working memory capacity is strongly correlated with fluid intelligence, reading comprehension, mathematical reasoning, and academic achievement, more so than raw short-term memory span. The bottleneck properties of working memory constrain almost all complex cognitive performance. The central executive is the supervisory component of Baddeley's working memory model that controls attention, coordinates the subsidiary slave systems, and manages the shifting and updating of information in working memory. It has limited capacity and is responsible for selecting and implementing strategies, switching between tasks, and dividing attention. The central executive is associated with prefrontal cortex function and is severely impaired in attention disorders, frontal lobe damage, and in aging. When you are multitasking ineffectively, you are experiencing central executive overload. The phonological loop is the working memory component that temporarily stores sound-based information. It is the inner ear and inner voice of working memory. The phonological store holds spoken information for about 1 to 2 seconds before it decays, while the articulatory rehearsal process refreshes it by mentally rehearsing the information, subvocally saying the information over and over. Reading comprehension depends heavily on the phonological loop because written words are typically converted to a phonological code before being processed. Articulatory suppression, saying an irrelevant word repeatedly while reading, dramatically impairs comprehension by blocking rehearsal. The visuospatial sketchpad is the working memory component responsible for maintaining visual and spatial information. It is the workspace for mental imagery, navigation, and visual reasoning. It stores and manipulates images, spatial relationships, and visual sequences. The sketchpad has 2 subcomponents, a visual cache that stores static visual pattern information, and an inner scribe that rehearses spatial and movement information. Chess masters use the visuospatial sketchpad to maintain mental representations of board positions. Driving while having a conversation is difficult partly because both tasks compete for visuospatial resources. John Sweller's cognitive load theory proposes that effective learning requires managing the total cognitive load placed on working memory. Intrinsic load is determined by the inherent complexity of the material, the number of interacting elements that must be held simultaneously in working memory. Extraneous load is created by poor instructional design, irrelevant information, distracting formats, and split attention effects that waste working memory capacity without benefiting learning. Germane load is the productive mental effort involved in schema formation and automation, which should be maximized. Effective instruction reduces extraneous load and manages intrinsic load while supporting germane load. The split attention effect occurs when learners must mentally integrate information from 2 physically separated sources, such as a diagram with separate explanatory text that must be read and then applied to the diagram. The cognitive effort required to search for and integrate the separated sources consumes working memory capacity that would otherwise be available for understanding the material itself. The solution is to physically integrate related information, place labels directly on diagrams, present explanatory text adjacent to the relevant figure. This simple design change significantly improves learning outcomes by reducing extraneous cognitive load. Counterintuitively, presenting the same information simultaneously in multiple formats, reading aloud from a slide while learners also read it, can actually impair learning compared to presenting it in one format only. This is the redundancy effect. Processing redundant information requires working memory resources that could be used for deeper processing. Effective multimedia learning combines complementary rather than redundant formats, narration with diagrams rather than narration with matching text. Students who read along while a teacher reads identical text aloud are experiencing induced cognitive load without benefit. George Miller's famous paper established that working memory can hold approximately 7 plus or minus 2 independent items, but the definition of an item is flexible. Through chunking, organizing items into larger meaningful units, experts can circumvent the strict capacity limit. A novice chess player sees individual pieces, a grandmaster sees strategic patterns, and the pattern is one chunk, not multiple pieces. Expert knowledge consists largely of an extensive library of chunks that allow complex configurations to be processed as single units in working memory, explaining why expertise in a domain produces such dramatic performance advantages. Alan Pivio's dual coding theory proposes that memory is enhanced when information is encoded in both verbal and visual formats simultaneously, because the two codes provide independent retrieval pathways. Find one, and you can often reconstruct the other. Concrete words, apple, elephant, are easier to remember than abstract words, justice, democracy, because they are more readily imagined, generating an automatic visual code to accompany the verbal one. This principle underlies the effectiveness of diagrams, illustrations, and concept maps as learning tools. They generate visual codes that the verbal information alone does not. Working memory is the stage on which all conscious cognition performs. Its limited capacity is not a flaw. It is a design constraint that forces efficient processing and schema formation. Understanding working memory gives teachers and learners alike a principled framework for designing instruction, practice, and study strategies that work with the architecture of mind rather than against it.